Hello everybody, welcome back. Today we're finishing off 5.6. We're looking at example 3, how to identify a linear relation. Which relation is linear? Justify the answer. And a new car is purchased for $24,000. Vehicles, if you're aware, would be the worst investment that you can have. Just an FYI, and you'll see in this question. It's not exactly accurate, but it's not far from the truth. A new car is purchased for $24,000. Every year, the value of the car decreases by 50%. The value is related to time. Okay, so we want to create a table of values for this relation. All right, so I'm going to get the calculator out for this. All right, so when you're creating a table of values, you're going to put your x here, so that'll be time, and the time in brackets is your units, is years. Okay, and the value is going to depend on how old the vehicle is, and the value is in dollars. Okay, so the time will start at 0, obviously, is $24,000. 1 year, 2 years, 3 years, and so on. Okay. Okay, so after 1 year, it says it loses by 15%. So I'm going to grab the calculator for this. So now that I have the calculator, if we have something at 15%, so where original value is at 100%, so we take 15, it's 85%. So change 85% to a decimal, we divide by 100. So it's 0.85, and then we multiply that by 24,000, and 20,400 is the value of our car after 1 year. Yes, your car has gone down $3,600. So we'll continue with that. So now we take this value and we can just hit multiply by decimal 85 again. So it's going to be 85% of that value again. We hit enter, and then after 2 years, it's going to be worth $17,340, and then we multiply that again by 85%. And we hit enter, so after 3 years, it's worth $14,739. So I'm going to put these values into our table. All right, that over. So it was 20,400, if I'm remembering that correctly. Next one was 17,340, and we don't use commas. That's a mistake, and sometimes I may do it, but we just put a space there. So after 3 years, the vehicle is only worth, it's almost down almost $10,000. Okay, so there is a constant change of adding 1 here. However, the value is not going down by the same difference. So the first time it went down 3,600, and then down by 3,060, and then down by 2,601. All right, so this is non-linear. All right, so I'm going to put that answer up for you, just so you can see that. What I just discussed. Okay, so everything I discussed there, I just wrote in there if you want to have something concrete to write down. So create a table of values, then check to see if the relation is linear. So as we discussed before, it adds up by 1. So time is obviously has a common difference, however the value does not. Both need to have a constant change. They obviously don't, so this is non-linear or not linear relation. Okay, let's look at a service call and electrician charges. So an electrician charges a flat rate of $75. So this electrician comes in your home, just walks in the door, regardless of how long they're there. It could be 5 seconds. The cost, $75. That's what a fixed cost represents. Okay? All right, and the time is in hours as indicated, and the cost is in dollars as indicated. Okay? So if he works 0 hours, comes in the door, oh yeah, it'll no longer work, you need no one, boom, $75. All right, I mean, that's his time. He has to drive to your house. There's different reasons for that, right? Okay, and again, this is negotiable, obviously, depending on we have, so, and for each hour he works, it's $50, it says. Okay, so $50 on top of that would be $125, and another 50 on that would be $175, another 50 on that would be $25, another 50 on that would be $275, right? Okay. and the total cost is related to time. All right. So obviously the time is increasing by a constant change of 1. The cost is also increasing at a constant change of 50, even though it started at 75. Every cost after that is adding up by 50. So this is indeed a linear relation we have here. Okay. So some of the I just wrote down some of the information for you, just as we talked about. After the first hour, it costs $50 per hour, right? So it's 75 for the first hour, and then every additional hour after that. Both have a constant common difference, so therefore this is indeed linear. Okay. So there's a check your understanding question to go with that. You guys can work on that on page 33. All right. We'll jump to example 4, and then we will be finished up the 5.6. Okay. So let's take a look. It says a water tank on a farm near Swift Current, Saskatchewan holds 6,000 liters. Graph A represents the tank being filled at a constant rate, and graph B represents the tank being emptied at a constant rate. Identify the independent and dependent variables. So for both graph A and B, the independent variable is time on the x-axis, or the horizontal axis, and represented by t in minutes, and the dependent variable is the volume, represented on the vertical or the y-axis, or the volume axis in this case, and that's represented by capital B. Okay. Usually, not all the time, but usually your y variable is will be uppercase. Again, it's not all the time, just an observation, and then lower. Again, that's not all the time. It says determine the rate of change of each relation and describe what it represents. So this is where we're going to do the change in the dependent over the change in the independent. So change dependent over change in independent. Okay, and we'll do that now. So when you're looking at the rate of change, it's the change in dependent over the change in independent, which could be short change in V over change in T, or the change in the volume over the change in T. We use this little, it looks like a triangle, it's called delta, delta V over delta T. All right, you'll use that in physics when you take physics. So you can pick any 2 points on here. It does not make a difference what point you pick. So because it's linear, so you can pick any. You can pick here, the first one and the last one, the middle ones, it doesn't make a difference. Okay, so I'll pick this one here, which is 20 and 1,000. All right, so, and then I'll pick 6,000, right? So I'll do the 6,000 minus the 1,000. Then you have to pick the corresponding times, obviously. So the corresponding time to 6,000 was 120, and the corresponding time to 1,000 was 20 minutes, right? Okay, and that's going to equal, I'm going to make this a little bit smaller just so I can keep it all in one line. All right. We'll insert the equation, obviously. All right, so that'll be 5,000 over 100, which is equal to, and again, you can put the liters in now if you want, the liters here, and the time is minutes. And then we divide the 2, and that'll give you 50 liters per minute. I just have to make that a little smaller so it'll be all in one line. I'll drop that to 10. That'll do it. Okay. So that means that the rate of change is 50 liters per minute. So that's, of course, you were filling this, right? So every minute, 50 liters of water is added to the tank. That's what that means. So you'll notice it's positive, so that means it's increasing. So as the volume increases as time goes by, so every 50, like I said, every 50 liters of water, every minute, sorry, 50 liters of water is added. So for graph B, we'll do the same thing. Again, you can pick any 2 points. I'll pick so the most left point will be, and it doesn't matter the way you subtract them, but I usually do like the final minus initial, or the most right point, most left point, or do you know what I mean? It doesn't make a difference. So I'll pick this one this time. So this one here is, we have 2,000 liters at 40 minutes. So I'll fill that in. 2,000 liters at 40 minutes. And that's going to subtract the initial. We'll do this one here at 20 minutes. It was 4,000 liters. So 4,000 liters That's 20 minutes, so that would be negative 2,000 liters over 20 minutes. And dividing the two, that would give you negative 100 liters per minute, right? So here, the rate of change is negative, so the volume is decreasing with time. Every minute, 100 liters of water are removed from the tank. Okay? So, and this is called slope. Rate of change is going to be your slope, and we're going to learn that again later on in the chapter. All right, so that's it for me. There's a check your understanding question there as well. I'll try to make some space for that right now. There it is. There's a check your understanding. And the answers go provided. There's a number of questions to work on. It's on page 308, numbers 3AC, 4AC, 6, 7, 9 through 12, 15, 16. And that's on page 34. Okay? Of this, but in your book on page 308. So in the next video, we will finish the chapters in the next couple of videos on 5.7, interpreting graphs of linear functions. So I just want to thank everybody for watching the videos. I hope they're helping. And if you have any questions at all, please let me know. Thanks again, and have a great day.